Hey everyone. So now that we know how to factor, we're going to be using those skills to solve quadratic equations. Let's get started. So here are some definitions that we need to know for today. The first one being a quadratic equation and function. This is very similar to the definition that we had with a quadratic expression, except this is an equation in the form of ax squared plus bx plus c equals 0. It can also be in the form of y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. The highest exponent must be 2. So here are some examples of quadratic equations. So here we have 5x squared plus 6x minus 10 equals 0, y equals x squared plus 4x plus 1, and then here we have a quadratic function, f of x equals 2x squared plus 7. Remember, f of x is just a fancy way of saying y. And notice all of these have equal signs. That's important. This is an equation, so there must be an equal sign. So we solve quadratic functions and equations in a variety of ways. First one being graphing. When we graph a quadratic equation, where that equation and that graph hits the x-axis, called the x-intercepts, those are our solutions. They're also called roots and zeros. So these are four different names for the same thing. But that's how we would find our answers when we're graphing. We can also do it by factoring, which is what we're going to focus on today. Something called the quadratic formula, and also a method called completing the square. Okay, so here we want to solve this quadratic equation by factoring. We have our math, we have our steps, and we know that we're going to factor here because this is factorable. If it's not factorable, you would do another method like quadratic formula or completing the square, but today we're going to look at equations that are all factorable. Okay, so the first step is to put the quadratic equation into standard form. Standard form meaning from highest exponent to lowest. So this is in standard form. And we have to make sure it's set equal to 0. It cannot be set equal to anything else. If that is the case, we'll have to move things around. We'll see an example like that after this slide. But it has to be set equal to 0 before you can start solving. Okay, the next step is to factor. Use whatever method best applies to the question. So we've seen a variety of different factoring. The AM method, we've seen slide, divide, bottoms up. We've seen GCF factoring, and we've seen the difference of perfect squares. So we have to really reflect, and we have to look at the question and understand which method best applies to the question. Because remember, each question is different, and each question can require a different method. So in this case, I see there's a trinomial, and my C is positive, my B is positive, so I'm going to use the AM method here. There's no GCF, so I know I can skip that. So we're going to find two numbers that when we add them, we get 13. When we multiply them, we get 36. Make your table if you need to. Start with the multiplication. What are two numbers that when I multiply them, they give me 36? So there's a bunch of different combinations there, but the combination we're looking for has to add up to 13. So those two numbers are 9 and 4. 9 times 4 is 36. 9 plus 4 is 13. So I'm going to create my two sets of parentheses, x plus 9, x plus 4. Remember, you can write the x plus 4 first or the x plus 9 first, doesn't matter the order. But I'm still going to make sure it's set equal to 0. That's important here. So we have to make sure we bring that down. Okay, so that was step 2. Step 3 is we're going to set both of these factors equal to 0 and solve using inverse operations. So this is what this is going to look like. So I like to draw a line straight down the middle of our parentheses, and I'm going to take each of these and set them equal to 0. We'll do that in blue. X plus 9 equals 0, and x plus 4 equals 0. The reason why we do this is because, remember, when we multiply these together, these two binomials together, we have to get 0. So that means either x plus 4 can equal 0 or x plus 9 can equal 0. They both can equal 0, but one of them has to equal 0 because 0 times anything is 0. Okay, so now let's solve this. I'm going to subtract 9 on both sides here. So we get x equals negative 9. And I'm going to subtract 4 on this side. Remember, inverse operations. So we're going to get x equals negative 4. So these are both numbers that if we were to plug this into our trinomial and evaluate it and simplify it, it would give us 0. That's what we're looking for. These are our solutions. If we were to graph this function, this is where this function would hit the x-axis. That's where our roots and zeros would be. So we set equal to 0, factor, and solve. Let's take a look at 2 more examples. Okay, here we have x squared minus 6x plus 20 equals 6x. So same thing, we want to solve all that for all values of x by factoring. So it's telling us we need to factor. First thing I notice is it's not set equal to 0. We need to change that. It needs to be set equal to 0. So what I'm going to do is I'm going to subtract 6x on both sides, but I'm going to make sure I line up my 6x with its like term. So I'm not going to put it under x squared because this doesn't have an x squared. And I'm not going to put it under 20 because 20 doesn't have an x. I'm going to put it under this 6x. That's really important where you place that. They have to be like terms. So I'm going to bring down anything I did not use. So x squared, and then that plus 20. Now, negative 6x minus 6x, same signs, add and keep. So this is going to become negative 12x equals, and these canceled out. Those are additive inverses. That would give us 0. So make sure that you move that because it has to be set equal to 0. From here, we're going to factor 2 numbers that when I add them, I get negative 12. When I multiply them, I get 20. My C is positive, my B is negative. So that's telling us that both numbers have to be negative. They have to be the same sign, and it is going to be the same sign as our B term. So 2 numbers that multiply to 20, add up to negative 12. Create your table if you need to. But the 2 numbers that satisfy that requirement is negative 10 and negative 2. Negative 10 plus negative 2 is negative 12. Negative 10 times negative 2 is a positive 20. So I'm going to write x minus 10, x minus 2 equals 0. And then from there, we're going to draw our line straight down, and we're going to set both of these equal to 0. From there, we solve using inverse operations. So this is negative in this example, so we're going to add 10 to both sides. That cancels, so we get x equals 10. And here we're going to add 2 to both sides. So we get x equals 2. So those are our roots, solutions, zeros, whatever you want to call them. Whenever we graph this, those would be our x-intercepts. Okay, let's take a look at this last example. First thing I notice, it's equal to 0, so I don't need to move anything around. And now I have x squared minus 81. This looks different than this example, so we have to use a different form of factoring. Hopefully in your head, a little bell went off and you said, oh, I recognize those numbers. Those are both perfect squares. So this is the difference, because we have subtraction, of perfect squares. So that's when we find the square root of the first term. So the square root of x squared is x. Square root of the second term, square root of 81 is 9, because 9 times 9 is 81. So then we create both our parentheses. So we get x and x, 9 and 9. And then remember, this is a conjugate binomial pair, so we do a plus and a minus. Now we still need to set this equal to 0 and do the same thing that we did before. We're going to draw a line down, set both of them equal to 0, and solve. From there, we subtract 9 on both sides for this one. So we get x equals negative 9. Here we're going to add 9 to both sides because it's negative. So we get x equals positive 9. Okay, so really 3 steps here. I know it might seem like a lot because we're doing different types of factoring, but make sure it's equal to 0. Use the correct factoring method. If you need to review the different factoring methods, please review the other past videos, and then make sure you set equal to 0 and solve using inverse operations. Good luck.